All right, so this is lesson 14 of Python for data analysis. And in this lesson, we're going to continue plotting with Seaborn. So Seaborn is a package that builds on the functionality of matplotlib, but it handles a lot of the work for you, so that you can focus more on quickly generating plots to see your data. And it provides a lot of cool functionality. So we'll talk all about that in a minute. So what we want to do first is go to lessons. Now this is lesson 14. You can see there's 7 notebooks. So we're going to only cover the first 5 here, but 6 and 7 are optional. And so we'll need to download each of these and then open them separately. So let us first go on lesson 14.1 and get that raw version. And we're going to do, let me try something here. I don't think this will work, but so we have this wget command. If you want to use wget instead of curl, you can do conda install wget. It works very similar to curl, except for you don't have to add the quotes and the dash o. But what I was going to do is see if this will work to do. No, I was going to see if it would accept wildcards. But it does not. So again, we can do wget or we can do curl-o, same thing, but we just need to go ahead and change the number here. So 14.1, 14.2, 14.3, 14.4, and 14.5. Again, you can either use curl -O in quotes, or you can use wget if you have that command. And now we're going to see, we should have these 5 lessons. If you already have your notebook open from the previous lesson, go ahead and switch to that. If not, again, make sure we're in the Python 3 environment and then type Jupyter Notebook. And now we see our lessons here. So let's click on 14.1. And one other thing we need to do is we need to go back to, here and get a new terminal. And since we opened the terminal from inside the notebook, we know that we're in the conda environment that we want. So we're going to do conda install Seaborn. So I've already done this, so it shouldn't ask me to do anything. Yeah. But for most of you, you probably haven't installed Seaborn yet, so you're going to type conda install Seaborn, and it will then ask you, and you say yes, and install that. So once that's done, we were ready to go with the tutorial.
Do you do this in the Python 3?
Yes. Yeah. You can either open up that little terminal window from the notebook, or you can go back to your terminal app. But either way, make sure that you're in your Python 3 environment, so that all the packages that you're installing will go into that environment. That just gives you more control over where things are installed, because when you create a new environment, you're going to want to have the ability to install separate packages there. Okay, so for the Seaborn lesson, we're gonna use the Seaborn tutorial that comes with the package, and this gives a really nice overview of all the features of Seaborn. We'll cover, there's like 7 modules, we'll cover 5 of them today, and then the other 2 are optional. They're in the GitHub, but I don't think we'll have time to go through those today. So the nice, as the way I see it, Seaborn has 2 advantages. One is that it provides a lot of nice plots that are easy to generate. So if we go, we open up a new tab and you go to seaborn.pydata.org, this will take you to the home page for Seaborn. And you can, again, just like Matplotlib, Seaborn has a gallery, so you can view this and quickly say, oh, okay, I want to make a heat map, and you can click on that, and it gives you some basic code to generate a heat map. So the nice thing is that you can see there's not a lot of lines of code. In fact, you can generate this really nice heat map with one command. You don't have to create the subplots and all that stuff. You can still do that, and in fact, using this, this is a great example. In this example, we are making subplots. So the way it works with Seaborn is that you can still create the subplots, which gives you all that extra Matplotlib power to change all those things. But then you can use this kind of canned function to plot to those axes. So you just specify ax equals whatever the name of your axes is. And here, in this case, it's also called ax. And that allows you to plot to those axes using the Seaborn function. But the nice thing about it is it gives you this really beautiful figure with just one line of code. So that's the one advantage of Seaborn. The other advantage is it gives you these really sophisticated ways of digging into your data. You can create distribution plots. We'll see these in a minute, where you can specify not just the x and the y coordinates, but something that's called the hue, which is like a third category that you want to divide your data by. In this case, it would be smokers and non-smokers in this data set. And so you can see those two sets, separate rows of data depending on the value of that category. And so it just gives you lots of, you'll see in a minute, all the different ways you can slice up your data using this package. So I think that's where it really shines. Okay, so if we go back to Seaborn, we're going to first see the most basic function of Seaborn, which is you're still using Matplotlib, but you're using the Seaborn aesthetics and coloring, and it will render your figure using Seaborn aesthetics. So we're gonna import Matplotlib, and again the main one we want here is matplotlib.pyplot as plt. Okay, and let me do one more thing. I'm gonna restart and clear output. Okay, so let's do this again. And we're just going to define a function that's going to generate a sine curve. And if we run that function, which then it doesn't just define the curve, but it plots the sine function. If we run that function in Matplotlib, we get these lines, and they're colored this way, and the plot's formatted this way. But if we then import Seaborn and switch to, I'm going to separate this off, switch to the Seaborn defaults, this is not necessary. I just wanted to offset these for emphasis. So there's two things that are happening here. One is we're importing Seaborn, and then we're running this command seaborn.set, or and specifically by convention, we're importing Seaborn as SNS. So just like NumPy is NP and Pandas is PD and matplotlib.pyplot is PLT, we're going to call Seaborn SNS. This is, you can call it whatever you want, but these are widely used conventions that you'll see, and it just makes it easier. You don't have to type the whole word. So this function set will set all of the plotting defaults to the Seaborn defaults. And so then when you create the sign plot, now we're getting the Seaborn defaults. So the colors of those lines is a little different. The grid, you're seeing a grid pattern, etc. And these can be controlled manually or using a number of different contexts that we'll see later. But this is kind of an aesthetic thing, you know. The gray background with the white grid lines is kind of makes it easier to see, you know, where the coordinates are in your plot. And there's some aesthetic choices that go into this, but and there again there are ways to customize this, but this is the default. So we will see that there are some different themes that we can use. So first of all, we're going to generate a data set that we're going to plot, and I'm just showing you I'm showing you the data just so you know what it's doing. Could probably make this a little. So we have ways of setting the style. So if we wanted, instead of this, this is called dark grid. If we instead wanted to use the style that's called white grid, we can set style white grid, and that will change the style. And then we're going to use a box plot this time instead of a this sign plot. But we've got other styles that we can use too. We've got dark, which has no grid lines, just a dark background, or white, which is more similar to the matplotlib defaults. And then we have ticks, which is like white but with tick marks. You can control all these in finer detail, but these are the kind of 5 defaults. So if you wanted to remove the top and right spines, Seaborn has this despine function. So we're in this notebook we're just covering some of the aesthetics, and then in the future lessons or future notebooks within this lesson we'll get into more of the different kinds of plots that we can do. So we can also, when we run despine, we can set an offset, which will offset the axes from each other to kind of give a little more space for the data, if that's what's needed. We can also despine the left side in addition to the right side and the top, which is what's done by default. So these are just some ways to change, you know, the basic grid that we've got. We've seen something similar to this in matplotlib, but these are the Seaborn versions of that. If we want to temporarily change the style, but not do it for the whole notebook, we can use a with command. Remember, we've seen the with before when we were doing opening and closing and reading and writing files. So the same idea here. This will temporarily change the style, and then we can go back to the original style. So here we're going to do a subplot. Again, this is using matplotlib. So this will actually activate the subplot and then plot that sine wave with a dark grid, and then it will go back to the defaults, which are a white grid, and plot that second subplot. So this is a way to just to temporarily use a different style. There's also ways to change the style. So if we want to see all the different parameters that we have, we can run sns.axis_style, and it will give us all these different parameters and their current settings. If we then want to change that, we can use the setStyle function and then specify where we want to do dark grid and then axis face color set to 0.9. So this will make it a darker color here. And then we can see that we've changed the value of axis face color from white to 0.9. So it gives us it still gives us the ability to control things, but with kind of nicer looking defaults. Another nice thing is that there are these contexts. So the styles are about like how you want your plot to look. If you want to have dark grid or white grid or tick marks, and depending on what kind of data you're showing and what your preference is, you can choose those. The context refers to how your data, where your data are going to be presented. Is it going to go in a paper? Is it going to go into a talk or a poster? And so you might want thicker lines or bigger fonts, and it will automatically reformat everything for that context. You don't have to manually specify the font size and all that stuff. So you could take the same notebook and the same figure and just change that context. Let's say you made the plot for a paper, but then you're giving a talk, and you want to just like regenerate that figure, making the fonts bigger so it looks good in the talk. You can use this set context thing. So first of all, we're going to reset all the parameters using this sns.set function. This will reset everything to the Seaborn defaults, and then we can set context to say paper. So this would this might look good in a paper where you can look carefully at the figure, whereas in a talk you might want bigger fonts, fatter lines, or in a poster you might want even bigger fonts and fatter lines. So you can play around with these, but it gives you a nice way to change a lot of things at once. There's also this ability to scale the font and using these what are called RC parameters to change the line width. So this gives you ability to kind of override the defaults by scaling the font and changing line widths manually. So that's the first part. That's controlling figure aesthetics. And so next we're going to go to lesson 2, and we're going to talk about choosing color palettes. So one of the nice things about Seaborn is it offers a lot of really sophisticated control over colors. And we'll talk about using categorical colors, which each color represents a different, like a different data set, for example, or a different variable. or continuous colors where you have a continuous value and you want to like going from dark blue to light blue, or a rainbow color map you sometimes see. So we'll talk about that and all the different ways you can customize. So first we're going to set up our settings here and import the packages that we need. So there's a function called color palette which can generate a color palette that you then use in your plotting. So we'll see how this works in a minute. So first we're going to set the Seaborn defaults using sns.set, and we're going to have a look at the current color palette, the default color palette. So just running sns.colorPalette will return the current palette. So we're going to call that current palette, and then this function palplot will display the color palette as just these squares, so we can see all the colors that we have. So this is why when we plotted like those 5 sine waves, they were blue, orange, green, red, and purple, because those were the first 5 colors in our color map. So this would support up to 10 different colors of data, and then if we had more than 10 things that we're plotting together, we would reuse the colors in this example. So you'd have to, if you had more than 10 things you were plotting, you'd have to change your color map to accommodate more colors. So the default theme is called Deep, and there are different versions of this: muted, pastel, bright, dark, and colorblind. Colorblind is a great one to use because it's more easily distinguished by people that are colorblind, so it's more accommodating to a diverse audience that might be reading your work or listening to your talk. So here I'm just going to make a loop where I'm going to loop through these different variations in theme. I'm going to save that theme as the current palette, and then set that, or then display that. So you can see these different themes, and you can pick which one you want. So, but we still haven't actually done anything. Even though I called it current palette, we didn't actually change the current palette. So if we plot, we're still going to get the default colors here. So to actually change to, let's say, most recently we had current palette was colorblind. That was the last thing we did. So if we change using set palette, using that variable current palette, we now should have, it's hard to see, but we now should have the colorblind versions of those colors. So if you have more than 6 or more than 10 categories to distinguish, you can use evenly distributed a color map. So we can do, here we can do HLS, which is like a rainbow. Let's see if this works. Yeah, so we can, let's say we had more than 10, we could do 12, and this would give us, some of these greens are a little hard to distinguish, but you can do it. We also have this HLS palette, which gives you more control over the lightness and saturation of the colors. So we can make it a little darker, a little more saturated. If you want evenly spaced hues, that this deals with how your eye sees color. It might not do as well with, it might perceive certain hues as brighter than others. So there's this HUSL system that balances out the the parent brightness and saturation. So you can use that. Another really nice option that we have is using these color brewer color maps. So if we click on color brewer, this takes us to this really neat website where we can choose color maps that will be the best for what we're trying to do. So for example, here we have 3, let's change it to like 6. We want 6 categories, and we want qualitative color map, and we want it to be colorblind safe, so there's actually nothing that works there. So let's dial this back to 4. So this would give us a qualitative color map that is colorblind safe, and so even if we couldn't distinguish colors as well, we'd still be able to tell the difference between these 4 colors. I like to use an app called Color Oracle. So this is for Mac. I'm guessing there's something similar for Windows and Unix. But what's cool about this is you can click on these different types of color blindness, and it will change your screen to what it looks like if you have this condition. So it makes it really easy to see. Oh yeah, they should be able to tell these colors apart. Even these other less common types of color blindness can still. This one's pretty hard to distinguish, but there's enough. There's still some differences there. So this is a nice feature. So Color Brewer is a really great resource. So anyway, so Seaborn supports Color Brewer, so you can use, for example, this paired one is the one that we just saw that's really useful for color blindness. So these first 4 colors would work, and you can get different numbers of colors. There's different lots of different options of different sets of colors. Another thing that the color palette supports, we saw this with Matplotlib as well, is that it supports RGB hex codes. So you can specify any color you want, and you can really have total control over coloring. Another really cool thing is this Xkcd color survey. So Xkcd is this webcomic, right? And he did a survey where he asked people to name random RGB colors, and this produced a set of 954 named colors, which if you click on this link here, hopefully this still works. Yep. So these are the 954 most common RGB monitored colors as defined by this color survey. So he had people put an English word to a color that they saw, and then combined all the results, and this is the results that you get. So the nice thing is that they kind of match our intuition about what the colors look like. You can then use these keywords as colors in your Seaborn graphs. So here we can have these 3 lines, and we're going to use, basically it's a dictionary. So the color will be the looked up value from this dictionary. So it's used sns.xkcd RGB, and then the name of the color. So here we can have our 3 lines will be rust, lilac, and navy, corresponding to those Xkcd colors. So this is another really handy way to get the colors that you want. You can puke green is good. Yeah. Yep. Sometimes the situation calls for it. So here's a list of colors. You can create a palette from those colors. using Xkcd Pallet, and that will then. So here we're using the plot, but you can also save this as your. You can set your palette in the same way, so you have now a color palette that you can use. So we also have sequential color palette. So everything we talked about up to this point was different categorical colors, where each color represents a different kind of unique category. Whereas sometimes you want to color your data on a continuous sequential spectrum from low to high. So for that, you could use a sequential color palette. Historically, you'll see people using this like jet color map, which is like a rainbow, but we tend to not want that because of this thing where your eye sees different colors with more brightness, even though they're not. And the other problem with the jet color map is that, in fact, oh, we don't have the post anymore, but the yellow is right in the middle of that color map, whereas yellow is like an intermediate values. So it's not something you particularly want to highlight. So much better to use one of these sequential color maps here. So if you just want a single color, you can use blues or greens. So Seaborn has blues, or you can do blue-green, and you can use the R suffix to reverse it. So instead of going from low to high, you can go from high to low. We also have these darker color maps, which go from a dark to light, but they also change the hue from blue to green. So that's pretty handy. Similarly, there's this cube helix palette system, which works really nicely to give you a lot of different hues, but it also, if you were to print this color map in black and white, you would still see the differences. So it really takes advantage of color. So even if you're colorblind, or even if you're printing on a black and white printer, you can still see the spectrum. But if you can see it in full color, you get more information. So I think it's a really nice option. And again, we've got some different options here with the Cube Helix palette. We can change our starting and rotation, or no, there's a lot of ways you can tweak this. You can play around with that. You can also reverse it, which, depending on your data, may be desirable. So to see this in action, here is a data set. We're going to make this multivariate normal distribution of 2 vectors, and then plot those as a kernel density plot. We'll see it in a subsequent notebook how we make the kernel density plots. But basically, we're showing the density of this data using this sequential color map, and it gives a really nice figure. There's also these light palette and dark palette options, which you can just choose a color and then light palette or dark palette, whether you want it to be going from the color to white, or from the color towards black, and that will give you those options. And again, you can reverse it, which is always nice to have that option. You can also generate, using that palette function, you can output as a color map, which can then be used in a figure such as this KDE plot or kernel density plot. And there's just a lot more options here of using different input colors. Could be an RGB color, or could be an Xkcd color if you specify the input as Xkcd. So you can make a color map from, what was it, the vomit?
Oh, there's actually, I've been playing with it now. There's also a vomit green and a puke green.
So you could make a color map from vomit green or puke green. So we could try this, yeah. There we go. Pretty cool. You could spend a lot of time getting your colors just the way you want it, but it's good. It's time well spent because you want your graphs to be legible and giving meaning. So another thing to point out is that you want to think carefully about how you do your colors, because we talked about categorical. We talked about categorical color palettes. We talked about sequential, going from like low to high. Related to sequential is a diverging color map, where you want to go from, with the low to high. Let's say you're more concerned with like just the low values, or more concerned with just the high values. Well, what if both the low and the high you want to highlight? So if let's say temperature, if in your data set only high temperature is really worrisome, say to your organism, for example, you might just want to use a sequential color map where only the high temperature draws your eye. But if low temperature is also bad for your organism, you might want a diverging color map that really draws your eye to both either low or high. So here you would want bright or dark colors on those extremes, and then in the center you would want more of a muted color. So this would be where you'd use a diverging color map. So for example, this one BRBG is such a color map where you have two colors, brown and green, brown and blue-green, or red and blue, that you're highlighting. We also have one called cool-warm, where there's a little less contrast between the middle values and the extremes. But if you want optimal control, you can use this diverging palette function, which gives you a lot more control over which colors you use, and then the number of colors that will be generated in your plot. And again, you can, if you want to have a continuous color map, you can export that as a color map rather than as a palette. This is one where you could have your center values being dark. So these are, if you're doing a heat map, for example, you might want to either have a, if you wanted to highlight both low and high values in your heat map, you could use a diverging color map. So if you want to change the default color map, you can use set palette. So here we're going to have this sign plot where we're going to set the palette ahead of time and then draw that plot. And again, we have this ability to do a with statement where we're only changing the color map for a single plot. So we changed that, but then if we went back and ran the sign plot again, we should get, we go back to the colors we had before. So the default for the notebook right now is this HUSL. And I could also do like blues. And then, or I could do reds. And then this one would still be using this with statement. It would be temporary, but the defaults would be, for the whole notebook, this would be the default. If I if I go to another notebook, or if I restart the notebook, then that would be lost.